All right, let's do the graphs of tangent and cotangent now. All right, now we're going to start off and generate them with a t-table, even though, like, when we do these graphs, we really don't do them with a t-table. Only the first time that we see them is when we do a t-table. So we're going to do tangent of x first. Okay. Now, one of the things that's going to be different about tangent and cotangent, the standard period here is not going to be 2 pi, but instead the period is just pi instead of 2 pi. Now, one thing that we do different from tangent than all of them, even from cotangent, is we offset it a little bit. All right, notice like when we do a graph, like a normal graph, we go from 0 to 2 pi, and we do 4 units out this way. Instead, what we're going to do is we're going to back it up, so it's going to have 2 units on the left side and 2 units on the right side. Okay, it won't start off that way, but that's the way it's going to end up. Now, you'll see that better when we get the graph. Now, I want you to look at your unit circle with me. And so when we offset it, instead of going from 0 to pi, I'm going to go from negative pi over 2 to positive pi over 2. Okay, y'all think about that. Now, if I went from negative pi over 2 to pi over 2, that would be a distance of pi, wouldn't it? Like a half a pi and a half a pi, make a whole of pi. All right. Now, and what helps us get the graph are, of course, the quadrantal ones, the 3 quadrantal ones, and the ones that are halfway in between in each quadrant. What's this angle that's like halfway in between? Not this one. Yeah, 45 in terms of radians, though. Yeah, pi over 4. Okay. Now, when we name this angle down here, a lot of times we would name that like 7 pi over 4. How would we name it, though, if we were going in the clockwise direction? It'd be negative. So it would be negative pi over 4. Okay. Now, let's look at all the ordered pairs for them. All right, this one would be what? 0, negative 1. Okay. This one would be what? Square root of 2 over 2. And negative square root of 2 over 2. Did I get my signs right? Okay. All right, this one would be, oh, I almost got it backwards. 1, 0. Right. And now, while we're doing the rest of them, let's remember, how do we find tangent? That's what we're graphing. Sine over cosine. Okay. Now, so let's make a little t-table. X, Y. Now we're going to list the angles from negative pi over 2 to pi over 2. So I have negative pi over 2, negative pi over 4. This one will be 0, pi over 4, and then pi over 2. Okay, now let's name, I'll put in the angle and see what would the tangent of the angle be for the y value. Okay, so what about the tangent of negative pi over 2? So we said tangent was sine over cosine, which would be doing the y over the x. So you get negative 1 over 0, undefined. Okay, when 0 is on the bottom, it's undefined. Okay, and that's going to be a characteristic about tangent and cotangent. The ends are always both going to be undefined, so it'll be nice. Now, at negative pi over 4, what's going to be my tangent there? Because we do sine over cosine there again. They're the same number, except you got a negative left over, so it would be negative 1. Right, what about at 0? Let's see, sine at 0 over 1 would be 0. So get the origin being one of the points. All right, now pi over 4, the tangent would just be 1, because they're the same number. And then 1 over 0 is again undefined. Okay, now let's draw this out. Now, remember, tangent is the only one. We call it, I say it's offset. Okay, Show you what I mean in just a minute. So we're going to need some room on the left side of the graph is really what's going to happen here. Now, so let's see, we're going to go 1, 2, 3, 4, but we're not going to end up using these two. Okay, we're going to put them there to help us get what these are, but later we're not going to need them. So what's this one going to, I'm sorry, what's this one going to be there? Pi, okay, as opposed to 2 pi, it's just pi. All right, so half of that would be pi over 2, half of that would be pi over 4, okay, and then it's pi over 4, 2 pi over 4, 3 pi over 4, okay. Now, but notice what else we said. We're going to offset it, right? We're going to have to put a negative pi over 2 and a negative pi over 4. So instead of going 2 units further out this way, we're going to offset it by 2 units over here, okay? So we'll have these two that are offset. And so it's going to center around the origin. You know how most of our graphs just went from like the y-axis onto the right? This is going to center around the y-axis and the origin. Now, what would this one be called, though? Yeah, negative pi over 4. And this one would be negative pi over 2. So now, what's going to happen, we only need 4 intervals there. So we don't really need these last 2. Okay, so if you want to, you can leave them there. But what I do is just kind of mark them out or erase them. So I'm not going to need any of these. Okay, so there's my pi one right there. So these I'm not worried about. All right, now we're not going to go in order when we put them off of our t-table because I want you to see a pattern. At negative pi over 2 and pi over 2, what do they have that's the same there? Right, which means that we'll have asymptotes. And I forgot something. What was my amplitude? 1, 1, and negative 1. Okay. Now, let's fill in the points right here. And I'm going to show you, a memorization technique where you're not going to have to remember this. All right. And it's pretty good because it's pretty visual. All right. At negative pi over 4, we're down at negative 1 right there. And then we're at the origin, 0, 0. And at pi over 4, we're up at 1. All right, so you see I got 3 points right here. That's not going to be a line that goes through these 3 points because think about what's on the end. Asymptotes. What do we do to asymptotes? Chase them. All right, so I tend to start mine in the middle and draw out and draw down and chase. So I'll go up through there. It's going to curve through there and chase. And then curve through there and chase. There's your tangent curve. So tangent's going to be the only one that I like offset to the left a little bit. Do what now? No, we're not going to offset cotangent. The problem that we get when we don't offset it is the curve is separated into 2 separate pieces. Okay, this way when you offset, you just get 1 complete curve instead of 2. If I did another one over here, what would have happened at like 3 pi over 4 and at pi is it would have chased down this way. And so it's kind of like I get 2 halves of curves and they don't match up. So it looks a lot better when you offset it. Now, let's look at cotangent. And then once we get tangent and cotangent, and then we can put them side by side, there's going to be a lot easier way I can teach you to memorize them here. All right, so let's do y equal cotangent x. Now, the period, just like tangent, is still going to be pi, not 2 pi like it was on our first 4. Now, we're not going to offset cotangent. So on cotangent, we're going to go from 0 to pi. We're going to use these halfway points and these quadrantal ones, just like we did with tangent. So halfway, this is what there, pi over 4. Okay, this would be pi over 2. What about this one? Yeah, 3 pi over 4. Let me put my ordered pairs here. We got 1, 0, square root of 2 over 2, square root of 2 over 2. All right, what about that one? 0, 1. Is that right? Yeah. All right. And then 3 pi over 4 would be negative square root of 2 over 2 and square root of 2 over 2. And then at pi, it's going to be negative 1, 0. All right, let's get our t-table going. All right, so we're going to go from 0 to pi. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay. Now, let's put in each of the angles. And let's remember, how do we calculate cotangent with our ordered pairs there? Cosine over sine. Tangent is sine over cosine. Okay, so cotangent is cosine over sine, which would be the x coordinate over the y coordinate. Now, let's see what happens at 0 here. So cosine over sine, I'm going to put 1 over 0, undefined. Yeah. All right, at pi over 4, all right, my tangent there, or my cotangent is going to be 1. All right, cosine over sine there, 0 over 1 is just 0. All right, my cotangent here, one of them's negative, so that's just going to make it negative 1. All right, and pi, cosine over sine, negative 1 over 0 is going to be undefined. So what are you going to notice about the graphs? Just like with tangent, the ends are asymptotes. Okay, so that's the nice thing about it. That only works when you offset tangent, though. So there's another reason why you offset tangent is both ends are asymptotes. Okay, so you're chasing on both sides. And you just have some kind of weird looking curve in the middle. All right, now let's draw the graph. And now I'm not going to need to offset this one, so I don't really need any space over here. So 1, 2, 3, 4. All right, what's this last one going to be over here now? Pi. All right, and then half would be pi over 2. And then half of pi over 2. Yeah. So you're counting by pi over 4. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Okay. Now, so let's do the ends first. All right, now let's fill in the middle part. So we got at pi, oh, I got to do my amplitude. 1, negative 1. All right, so pi over 4, we're up at 1. Pi over 2, we're at 0. And then 3 pi over 4, we're at negative 1. Okay, now how do we draw the curve? All right, what do curves do to asymptote? Chase. Okay, so this half of it is going to chase that asymptote upwards, and then this one's going to chase that asymptote downward. Okay, now I have a real clever way of remembering this. Okay, have you ever seen Saturday Night Fever with John Travolta in the 70s? Okay. Anybody want to show me what he looks like when he's in his white laser suit? No? Okay. Well, hang on. I gotta switch over to my computer. Hang on. I'm gonna show you a picture. Okay. That's right. You got it. You want to show that for everybody, Jay? I will. Hang on. There we go. Okay. So, all right. Does it look like a tangent or a cotangent graph to you? All right. So his left hand is up and his right hand is down. Now look back at your graphs. Okay. Which one had left hand up? Cotangent. So if it's a cotangent graph, my left hand should be up and my right hand should be down. Now, what does tangent look like? Right hand up, left hand down, but he's scooted over, right? Because he's offset. All right, so you watch this. Hang on. I gotta. Oh, it won't do it there for me because I turned that part. Yes. All right. So here, what is this? Cotangent. All right. That's how you're going to remember that. So you don't have to remember where each point goes. You just think, which hand is up? Okay. Where are the asymptotes? Which one do I offset? So I put a little summary for you right here. Okay. Let me switch it back over. All right. So when I've got tangent, this is what I remember. Right hand up. Okay. So John Travolta all posed. Right hand up, left hand down. Both ends are asymptotes, but it's offset. So it only goes to negative pi over 2 to pi over 2. And then cotangent, the left hand goes up, and it's not offset. So if you remember all this stuff, you don't really need to do all that T-table junk every time, okay? I don't know how I'd remember that if it wasn't for John Travolta. John Travolta's contribution to math. I'm sure that's why they made that movie. Did anybody ever watch? I've never watched the whole movie. Yeah, I can see that. Your parents are. My parents weren't really, or much older, so they didn't really watch that kind of stuff. But I could see where y'all's parents would probably really know this movie. Very beginning scenes, carrying a paint can down the street in his white leisure suit. I mean, he's got the strut. And he's sitting at the dinner table with his folks. His dad smacks him on the back of the head for saying something or doing something. He's like, "Don't mess up the hair." That's like the most famous line. "Don't mess up the hair." He was concerned about his hair. He didn't care. He got smacked in the head. All right. All right, y'all got this down? Okay. Now, let's do some graphs where we change up the amplitude and change up the period now. Okay. So for the most part, that's the way they look. Now we're going to change the numbers up and see what happens with it. All right, let's do at least a couple here. All right. Let's do an example like this. Y equals 2 tangent of x over 2. So now you can definitely tell it's going to change up the period. It's changing up the amplitude. All right, what's the amplitude? All right. Now, remember what we said about the period for tangent and cotangent? It's pi. Not 2 pi, just pi. So when we find the period for tangent, it's going to be pi over b and not 2 pi over b, right? So pi over b, let's look at this. Pi divided by, what's our b value? 1/2. Okay, because that's like 1/2 x, right? So it'd be pi divided by half. So we'll say pi times 2, which would be 2 pi. Now, all right, let's draw it out. But we're going to remember something about tangent when we draw the graph. It's offset. That means we're going to need some information on the left-hand side over here. So my left-hand side is going to go out a little bit further. Now, we may go all the way out to the right to get 2 pi, but we're not going to use all of this over here because it's going to center around the origin with my tangent one here. Okay. Now, so let's go out to 2 pi. 1, 2, 3, 4. So it'll be 2 pi. All right, what about this one now? Pi, pi over 2, pi over 2, 2 pi over 2, 3 pi over 2. Now, let's offset. Okay, so this one would be negative pi over 2 and then negative pi. So it's not going to be necessary for these two, are they? The only thing that this helped me do was get these numbers over here correct. Okay, so I'm really not going to need any of this part to get the full cycle. Okay, now let's talk about it here. All right, the rest of it is going to be memorization. Okay, what goes on the ends? Asymptotes. Okay, now let's picture John Travolta. It's tangent. Which hand is up? Right hand up, left hand down. Okay, so here's his body. Let's think of this as like his waist right here. Okay, so on the right side, what he said, his right hand would be up, right? So his right hand's going to be up where? 2. Okay, so put 2 and -2. Probably should have labeled that a little bit earlier. All right, but pi over 2, that's the right-hand side of his body. His right hand's going to be up. Now, his waist never moves, does it? So his waist is always in the middle. And then at -pi over 2, his left hand is down. Okay, see how that's going to help you remember that? All right, tangent, you got John Travolta with his right hand up. Now, let me ask you something. Let's see if you can figure this out. What if we made it a negative tangent graph? What if we made it like -2 tangent? Right, it'd still be 2, but the graph, right, the left hand would be up instead of the right hand. So if it's a negative tangent, instead of right hand going up, left hand would have went up. Okay, we might do one like that in just a minute here. All right, let's switch to a cotangent one now. Is that okay for that one now? All right, let's do a cotangent. So y equals 3 cotangent. Let's do 3/4 x. All right, so we got amplitude is 3. All right, but the period. Okay, y'all tell me the period now. Pi over 3/4. Okay, now let's calculate that. So this would be pi times 4 over 3. So we're going to get 4 pi over 3. Now, hey, get back over there on your stool. Go. Go get back over there. Go get back over there. All right, so there's our period. All right, let's count out to it. So we go 1, 2, 3, 4. And let's think with what cotangent, we're not going to offset it over here, are we? That's only with tangent. All right, so 4 pi over 3. It's a little bit hard counting by that one. All right, so let's half it to get to here. Now remember, to half, you take what, the bottom number, multiply it by 2. So this would be 4 pi over 6, which is 2 pi over 3. All right, let's half it again. So multiply this one by 2 again. That's going to give me 2 pi over 6, which is pi over 3. So we're counting by pi over 3. Think about it. 4 pi over 3, we divide it up into 4 equal sections. They're going to be pi over 3. So pi over 3, 2 pi over 3, pi. So really, we'd say it's what? 3 pi over 3. Okay, and then 4 pi over 3. All right. Now, the rest of it is just memorization. John Travolta, which hand is up? Is it offset or not? Okay, so not offset, right? All right, what goes on the ends? Asymptotes, all right? Oh, I forgot my amplitude. Let's put that in. I know, because it's probably like the least important thing because it's so easy. Okay, all right, so asymptote, asymptote. All right, now let's see. Cotangent, which hand's up? Left hand up, right hand down. Okay, so what's his left hand here? Pi over 3. Okay, so left hand up, that means his left hand's going to be up at 3. And this will be like his belt buckle. And then right hand down, so at pi, his right hand's going to be at -3. Let's have trouble drawing the right-hand sides of them. There we go. All right, now let's talk about this. What if we made that negative there? Right, so the right hand would have went up, left hand would have went down. So it looked more like a tangent graph, but shifted over to the right from the way that we draw it. All right, let's do, y'all want to do one now where we throw a negative in the front? Sure. We will later. Okay. And really, we're going to concentrate more on sine and cosine when we do that. Okay. I don't really think we'll do it with tangent or cotangent. Okay. But yeah, I think that's one of the things we're going to do like on Wednesday. Is we'll take a picture, or you'll look at a picture of the graph and kind of tell me what the equation is for it. Okay. I was looking for one that had a negative in there. I guess I can just make one up. All right, let's try this one, and then this will be good enough. All right, let's do -4 tangent. Somebody give me a b, put in front of my x here. 2, 3 over 2. Okay. All right, so 3 over 2x. It's going to make some nasty fractions come up. That's all right. All right, so I got amplitude is not -4, it's just 4. All right, period, pi over b, not 2 pi over b, just pi over b. So pi over 3/2. So it'll be pi times 2/3, which would be 2 pi over 3. All right, let's draw it out. Now, it's tangent, so I'm going to need some over here. Okay. And then go 1, 2, 3, 4. So this one's going to be 2 pi over 3. All right, what's half of that? Would be 2 pi over 6, which would be pi over 3. And then half of that, pi over 6. We got pi over 6, 2 pi over 6. 3 pi over 6 would be pi over 2. Okay. Now, over here, though, we're going to need negative pi over 6 and then negative pi over 3. Now, here's where a lot of people mess up. They remember, okay, that we're going to put asymptotes on the ends. So they put an asymptote over here, and then they put an asymptote way over here. See the problem there? We don't need the last two, and they forget that. Since it's offset, see, you only need like 4 intervals, don't you? You don't need all 6 of these. So since we offset it over here to the left, then this is all we need. We really don't need the pi over 2 and 2 pi over 3. See, all we did was let the 2 pi over 3 help me figure out what these two were going to be, okay, by doing that half strategy. So I really don't need that part. So you could probably, I mark it out because my eraser doesn't work too good. So I just mark it out, but you could erase it, okay? Now, so let's see, what's on the ends now? Asymptotes. Okay, now it's a tangent, so right hand goes up, but it's negative, so left hand would go up and right hand would go down. Okay, so let's see, left hand, my amplitude, so left hand would go up, even though it's a tangent, and the reason why left hand's going up is because it's negative. All right, middle stays in the middle, and now my right hand's going to go down. Stay alive. Stay alive. Stay alive. And you have to sing that when you do the graphs. That's a requirement. I know, everybody passed out. Man, I'd really cut out if my sinuses wasn't so messed up. Big old falsetto voice. It could be written as two different ways. Okay, so you could write this graph. Well, one reason I think you could say it would be tangent is because it's offset. Okay, and so because the left hand is up, well, that means it must have been negative. Okay, but I really don't think we're going to look at any tangent graphs that you're going to have to write the equation for. The ones that you're going to have to write the equations for later on, like Wednesday, is just sine and cosine graphs. Okay. All right. Now, on the back of your worksheet there, you've got some tangent and cotangent problems. Okay, I don't think I assigned you all of them. Look and see which ones I said there. All right, 6 through 9. And then 17, 19, and 21. So tomorrow, what we'll do, we'll go over any questions that you got. I'll get you your answers up for you. And then we'll do the quiz. We won't do anything new tomorrow. Okay. We'll just go over these and then take that really, really basic quiz. Okay. Yeah, just watch your videos. You'll be fine. Okay.